Okay, hello, and today I'll try something different. Rather than give a brief summary on the lesson's highlights, I'll just give myself a feedback on the question I asked during the class, which was on Madison's rule. And the Madison's rule is basically how to get is the carrier mobility of an electron is a combination of different kind of scatterings, lattice scattering, surface roughness scattering, and impurity scattering. And the question I asked was that if I multiply the total energy on the Masonian's rule, does it become the total carrier velocity? And the answer was yes, it becomes the total carrier velocity, but the total carrier drift velocity. And the reason why I asked this question was I was kind of confused on the whole scattering. I didn't know the difference. I thought that scattering and the drift was whole different ideas. So in my mind, I was like, okay, so we can kind of like get the scattering carrier mobility in the Madison's rule. Okay, so if I multiply the energy, it becomes the scattering velocity, and if I add the drift velocity, it becomes the total velocity, the total carrier velocity. And I think my professor caught my confusion in my question, so he kind of asked, "Oh, which velocity were you meaning? Like, what velocity?" And I couldn't give an answer because I was basically confusing the whole velocity, confusing the whole scattering and drift velocity thing. And by reviewing these lessons, like I finally knew that the scattering and drift are basically the same thing. So me thinking like adding the scattering velocity and the drift velocity is a dumb thing. So and in retaliation of that mistake, I did some further research on the Madison's rule, and I found out in various sources, Wikipedia and some other stuff, that Madison's rule applies in metals. Which was kind of funny that I thought in the lessons Madison's rule kind of applied in silicons or other different materials, and that's when I found out that, oh, so in metal you mean like it kind of works the same in degenerate semiconductor, isn't it? Because we learned that in that kind of material, in degenerate semiconductor, it works like a metal. Okay, so I kind of learned that, okay, the reason why we learn degenerate semiconductors because it's a metal, it applies, the Madison's rule applies. Okay, so that's a plus. And another thing I found was in Madison's rules, there's another factor, basically the defect factor. Now, I don't know that, I kind of think the surface roughness scattering is basically a defect factor, but the audio recording on the last lesson is lost, so I can't like check the facts on that kind of certain thing. So maybe that's a question for another day. Anyways, thank you for listening. This is Young Kim of class number 3.